let's jump in and talk about all the things you might need to know about absolute value for the ACT. First of all, the absolute value symbol is just two vertical lines. So it almost looks like parentheses. If you say, well, what is the absolute value of 7? The answer is 7. Absolute value signifies the distance from 0. So if I said, what's the absolute value of -7? That is also 7, because -7 is 7 units from 0. So really, you're always going to return a positive answer. So if we said, what's the absolute value of 5 minus 9? Well, of course, 5 minus 9 is -4, but the absolute value of that would be +4. Now, this is just always, returning the positive answer. But what if we were to say something like this? The absolute value of some number x is equal to 5. Well, of course, very easy to say, well, then x needs to be 5. But remember, a value of -5 would also have an absolute value of +5. So there are two answers. Now, I want to show you the graph of absolute value and talk about why it has two answers, but we'll do that when I show you how to do absolute value on your calculator. So let's make this a little bit harder. What if we said the absolute value of 3 times a number is equal to 12? Well, obviously 3 times 4 would be 12, but 3 times -4 would be -12, but the absolute value would be 12. The way to solve these is usually to think about it as solving two problems. One equal to +12 and one equal to -12. And then solving those just by dividing both sides by 3. And that's how you get your +4 and -4. Okay, let's solve one more of those. Let's say we have the absolute value of 2x plus 5 equals 17. Well, again, I would say let's shoot this off into two problems. One where 2x plus 5 is equal to 17, and the other where 2x plus 5 is equal to -17. Well, we'd subtract 5, normal algebra steps. 2x is 12. We'd subtract 5 here as well. Be a little careful with our negatives. 2x is -22. Divide by 2. So 12 divided by 2 is 6. -22 divided by 2 is -11. And there are two solutions. Now, the absolute hardest kind of problems with these would be to do something like this, like 3 times the absolute value of 4x plus 1 equal -7 equals 52. I'm making all of this up. And in this case, what I would do is try to isolate the absolute value. Okay? I would treat this almost like its own variable, like 3 times something minus 7 equals 52. And I would proceed like this absolute value thing is just a big variable. So I would say, okay, well, I'm going to add 7 because that's how we usually begin. So I have 3 times that absolute value. I divide both sides by 3. And then I would set up my two problems. I would say 4x plus 1 equals 59 over 3. And 4x plus 1 equals -59 over 3. But I would do all of that work to isolate the absolute value first. Let's look at how you do this on your calculator. I'm not going to finish this problem. All right, so let me show you how to graph the absolute value function. First of all, just where it is, if you go to math and then over to numbers, it's the very first thing, ABS, absolute value. And some calculators have the symbol built in, and you could say like, okay, -7, and enter, +7. Others actually just leave it as ABS, but it does exactly the same thing. So the problem that I didn't solve on the previous slide, turn everything off here, was 3 I'm going to go math, number, absolute value, of 4x plus 1. And then I want to get out of there, so I'm going to hit the arrow, minus 7. Okay? Now, if you remember, I said I wanted to know when this was equal to 52. So, first, I'm just going to hit a graph, and I'm just going to do a standard graph for a second just to talk about the shape. You can see the absolute value returns a shape that's kind of a V shape. And that's why we have two answers. You know, when we say, well, when does this function hit, and we draw a line across what the y values we want to hit, that's why there are two answers. Now, obviously, we can't see 52. That isn't in our window. So we could either try and do a zoom fit, which sometimes works, sometimes doesn't, tries to kind of see everything in our graph. You can see it actually, I think it's going to work here. There's my absolute value function. There's that 52, that line at 52. And I'm going to do second trace. This gives me some calculate options. Go down to intersect. And you see, it asks us, I like to get a little bit closer to the intersection points. But first curve is the absolute value. Second curve is just the line. I don't take a guess, but there it is. 4.6 repeating is one x value that does it. To get the other, we just redo that second trace, and we just want to zoom, or we want to use our arrows to get closer to that other intersection point. First curve, second curve, I'm not going to take a guess, but negative 5.16 with the 6 repeating. So this is a fast way to solve. If you have your calculator with you for the ACT, this would maybe be a better way to quickly solve those problems.